Assalamu alaikum, dear students. Dear students, level second year, subject mathematics, unit number 6. Dear students, our today's topic is plane analytic geometry. In order to start plane analytic geometry, it will be better to know some background for the plane analytic geometry. Dear students, in the past there were two French mathematicians. One was René Descartes, whose time duration is from 1596 to 1650, and the other one is Pierre de Fermat, and he lived from 1601 to 1665. These two mathematicians independently developed plane analytic geometry. To study or start precisely plane analytic geometry, we are going to first answer this question, that why study plane analytic geometry? Why we are going to teach plane analytic geometry to the students? What is the story behind this question? So dear students, science and engineering are the most important fields for the development of the nature and social development and any other things. So we see that science and engineering involves the study of quantities that change relative to each other. When we are dealing in the field of science and engineering, so we encounter quantities. Those quantities are related to each other. So if one quantity is going to change, then the dependent quantity is also start changing with that. In order to study those relative changes, so we need, and plane analytic geometry is that forum where we can make easy to study those relative changes between the quantities. For example, you may have seen in the physics that there are the two quantities, distance and time, and we are going to study the relationship between distance and time for a moving body. And from that relation we get insight that what type of relation is there for between the distance and time for that moving body. And in the same manner, we are going to study the relationship between velocity and time for a moving body. Population time, that the population of certain area is going to change with respect to time, and in order to study the relationship between the population and the time, we are going to refer to plane analytic geometry, and similarly force distance relationship can be studied. So dear students, in order to understand science and engineering in an easier way, then it requires to get mastering in the plane analytic geometry. So that's why we are going to study plane analytic geometry. Now let me start the base for the plane analytic geometry, and first of all I am going to tell you about plane, that what is actually plane is. Plane is an infinite flat surface. The word plane means geometrically or physically any infinite flat surface is called plane. Like this, the ground level of this room or this board width length, this is called plane. So any infinite or finite flat surface is called plane. In order to study plane and things and the objects are in the plane, so that is what we call plane analytic geometry. Actually, study involves two concepts. One is geometric representation and the other one is algebraic representation. And you see that algebraic representation for a relation, algebraic representation between the two quantities is an equation. Equation is a tool in algebra. Equation is a tool in algebra with the help of which we present the relationship between two or more quantities, and the same equation can be geometrically represented by graph. In order to make it easy to understand the relationship between the quantities of which equation is there, algebraic representation equation is there, then to make it easier and to get understanding properly, we draw the graph of this equation, and from that graph then we deduce their characteristic. The relationship between those quantities can be analyzed from their graph. In order to move that how we can do this, so let me first introduce Cartesian plane. Dear students, if we draw the two lines perpendicular which intersect each other at this point O, having coordinates 0, 0, these two lines makes this first quadrant. In this first quadrant, we can plot a point, let's say P point, we can plot, and this point has coordinates x and y. X is the directed distance from the x-axis and y is the directed distance from the y-axis. So this point P has two coordinates in the plane, that is xy coordinate. And similarly, in order to clear that this is first quadrant, and in this first quadrant a point has two coordinates x and y which are both positive, because you see that right side of x-axis is considered positive, upper side of y-axis is considered positive, and this portion is called xy plane. So in xy plane, here in this first quadrant, the coordinates of the point are positive, x and y. Similarly, this is the second quadrant, and in this second quadrant, points in this region, every point has x coordinate negative and y coordinate positive. Here x coordinate of the point is negative and second coordinate of the point, that is y, is positive. This is the third quadrant, and in third quadrant point P has negative coordinates both. P has minus x and minus y coordinates. Similarly, in this fourth quadrant, P has two coordinates, x is positive one and y is negative one. So this is the Cartesian plane, and in this Cartesian plane we can locate a point, and in the same way we can draw line that is actually representing the relationship between the two quantities. So now we are going to further study different quantities with the help of this Cartesian plane. Dear students,